So good morning. My name is Wiebe. You can call me Wiebe. I removed the strings because the story for the strings is almost the same as arrays, so it would just complicate stuff. And normally when I make a presentation, it starts by submitting a title, and then I think a bit about it. Sometimes the other way around. Sometimes I have a thought and then submit the presentation. And then the procrastination starts, and then the more procrastination phase. And then usually like a day or two, I pick 10% of everything I thought of and then somehow get it done in 20% of the time that it should realistically take. However, this time, this event, previous week, there was a submission of presentations of GDevCon NA, and Greg Richardson presented on the exact same topic. So that threw me off a little bit, so I reverted to more procrastination. And then I thought, well, why not just, right? So. No, of course not. No, I'm not going to do that. So his presentation was a 7x7. So he covers the material, but in his own specific way. And I think I have a few things to add. So I'll start with a bit of theory, then some practice, and then scripting. So if there's no time, I just skip that part, right? That's the fun part, so I think for most of you. If you have any questions, just during the presentation, I don't mind usually. My clock hasn't started, so. And I didn't have any coffee, so it's going to take 10% longer. Anyway, yeah. Thanks. I got full 30 from now. Okay. So I didn't have any female giants for this topic, so I'll just put it in the chat. That seems to be the thing to do nowadays. I got this one. I couldn't know for sure that this has anything related to LabVIEW. And then I thought, well, I asked for a woman and not a female, so I changed the question, and I got an entirely different answer. Okay, but this one, this woman, I'm pretty sure it had an effect on LabVIEW because this book was written in '86, and that was around the time that probably the compilers in LabVIEW were developed. So I'm pretty sure this woman had effect in LabVIEW. So yeah, thanks to her. So in LabVIEW, wires, theoretically they are immutable. So there's no way for LabVIEW to change the value of this wire. Because if you split it, you would get the old value and not the changed value. So what LabVIEW does, if needed, it makes a copy of the data. But LabVIEW will prevent that if possible. But it's not always possible, and it's certainly not obviously when there is a copy and when it doesn't make a copy. The compiler, however, doesn't make copies of the data because that will make LabVIEW incredibly slow. So if LabVIEW can prevent a copy, then the data at the same pointer is changed, and that will be much more efficient. The data could be megabytes or more. There is one nice function in LabVIEW that you can use to show this. This is the array mem_info function. It's nowhere on the palette, but it shows the pointer. And you can actually.
What is this? What is this function?
Well, where it's from, yeah, okay. So it is a function, but it's nowhere on the palette.
So space
No, quick drop won't get it. Give it to you either. No. So yeah, how you get it? You use this one, yeah. So so you make a new VI that's not running, and then you generate the code with scripting. How did I find this? Well, this enum is type def. So if there's a new version of LabVIEW, you can generate this for all the items, all the elements in the type def. And there will be like 6 or 7 items that crash LabVIEW. And you'll find another lot of nice stuff like the target structure and other structures that are not functioning and future use maybe, but yeah. Oh, it has 7 probably, maybe earlier. It's been there for decades, yeah. So good to hear that you didn't know about the function, because it's a very nice one. If you have a debugger, you can actually go to the pointer and see the data. Yeah. So it can be deceiving, because over here you would assume that LabVIEW can prevent the copy of the data. However, this is a constant, so the next time you run, it needs to be in memory still, so it cannot avoid a copy. So you get 2 different pointers. If you use an init from array, this data can be recreated the next time you run LabVIEW. So you can reuse the memory, right? It's quite, they put some thought in it, pretty sure. Another thing is that if you don't do the add, the array stays intact in the original form. And it won't even initialize the array again, it will just reuse the memory that's there. So it's very efficient, and it's really nice that in LabVIEW you don't have to think about arrays too much. If you ever go to C or C++ or C#, then arrays are like a big part of the book on it. Yeah. So subarrays. LabVIEW can do another trick when you have a subarray, because this is the entire array, and the subarray can still point to that data, right? So if you get the pointer, you see that the pointers are the same. It's just that it marks a subarray. So there's more to this structure in memory of LabVIEW, pointing the subarray data to the original data, right? And that way you can avoid a copy. The subarray could still be megabytes or kilobytes, and then if you call that kilohertz rate, then it's still very inefficient. So, very nice trick, LabVIEW pulls.
Is it necessary to use this method to figure out if the output's a subarray or not?
No. Thanks, Norman. No, this is one trick to. This trick has the disadvantage that you actually need to modify your code, so you have to put it in there. Obviously, when you're going to release your code, you probably want to take it out. So, no, there are more tricks. We'll get to that. Hopefully. Yeah. I think we'll do. I'm doing great without the coffee. Yeah, so that's just a duplicate sheet. I didn't remove that. So you should be careful, because it might seem obvious, but this is a split array, and this is a delete from array. And the result will be the same. However, this one takes 8 seconds, and this one will take 2 milliseconds, right? That's because this one the delete from array will never create a subarray. And the split array will, right? So, yeah. It can be quite significant, the change. Here's one of my VIs that I found in the field. This is the cleaned version, inherited code. Nothing too wrong about this. The other cases implement similar stuff. And well, this would be a subarray, but this wouldn't, and I'll get to that later. This is the optimized version, and that reduced 5% of my CPU time. So just this VI. The entire application was 40%, so 5% was quite significant. Just one VI, if you do it correctly. So how would you go about this? How would you go from this to this? You certainly don't want to insert all the RMM info nodes in here in every case. So a profiler, yeah, you start by a profiler, right? You identify the VIs that would need optimization. Benchmarking, that's even harder. You actually have to make the benchmark. Show buffer allocations. I'll show you later. It's not lying, but it's not the entire truth. That's telling you. So experience, yeah, that helps. If you've done it a few times, you'll know stuff and you go about it faster. And then there's the help, the LabVIEW help. I'll show later as well. Show buffer allocations. So I only turned on the arrays, and there's a buffer allocation there. So this is the fast version. This was the 2 milliseconds version. And you would think from the information that this shows you that there's a buffer allocation, and there is, but it's the allocation of the subarray, not the allocation of the array. So there's no copying of data, although you would probably think it would copy the data there. So regarding to subarrays, you cannot count on the show buffer allocations. Of course, if you can remove the buffer allocations entirely, it would be fast as well. Yeah. That didn't appear automatically. So Greg shows a presentation. It's blocked by my note about Copilot. I was thinking, this is Greg's list, so just call it Greg's list. And I had to ask Copilot if that was funny. It is funny, so you should laugh, right? Copilot says it's funny, yeah. And if you have a list of nodes, we could actually, if there was a tool that could search for search in VIs, you could actually make a query like this and get the nodes that are not returning subarrays. This tool is still in development. See my presentation last year. It's on YouTube. Yeah. But even if you only use the correct nodes, the nodes that return subarrays, there's much more to it. Because if you start using the node in a case structure, like this, the other case is empty, then you get 22 seconds execution time. So apparently, what happens is this is a subarray, but the other case is empty, so the result will be a copy here, because this cannot be a subarray, because the other case doesn't return a subarray, right? If you put the delete from array here, you are back to 8 seconds. So that's kind of like tricky. There's no other way to put it. This is fast, and then this makes it extra slow, and then the slow solution is just as slow as. Oh. But in the other case, if we don't use this default but create an empty array, this is still an empty array, then we're back to 2 milliseconds, right? So it's very clever what the compiler is doing. But it might not always be what you want, and it might not always be what you expect. Yeah, and this trick only works if the source of the array is the same. Right? However, if you want data in there, you can actually insert the data, and it still points to the original data, and it will still be fast. But you would have a copy. Yeah, it's, sadly, the only thing we have to go on is the LabVIEW help. Really. So in the help, LabVIEW will show array or subarray. And that only works if the VI actually was open when you compiled it. Greg mentioned that the VI should be compiled, but that is a bit ambiguous. If the VI is compiled and you load it first, then you still don't get this information. You first have to run the VI once, in my experience. So I'll show a more advanced example. This is a movie, right? Yeah. So this is the VI I showed earlier, and it doesn't say subarrays. I run the VI, still doesn't say subarrays, because it was already compiled, so running it won't recompile it. Here I press Control, and now it recompiled, and now it says subarray, right? One other thing to notice is that this VI is reentrant for extra performance, and LabVIEW even made the input wire a subarray, right? So in a reentrant VI, you could use the VI and the entire chain would be a subarray. So that gives you really a boost if you can avoid copies. So, yeah, how much time? Oh, there will be room for questions, yeah. And we have some time to catch up, so, yeah. So, enter the dark side. Who in the crowd has scripting experience? Who knows what scripting is? Let's start there. Who has no clue what scripting is? Is there nobody? One hand? Okay. So you can ask anybody during a break, because they all know about scripting, right? You can ask me as well. Yeah. So why would you like to automate things? Well, maybe you could make a VI analyzer script, right? That would be great. You could actually make a script to say, oh, well, your code isn't performing and you get a negative result from your VI analyzer. I don't use VI analyzer, but I think that it's feasible. This is brown. Not on the screen, it's more green, but it's brown. The brown nodes, those are like the extra super secret scripting nodes. Just enter scripting LabVIEW and you'll immediately go to the Wikipedia page, and you have to turn it on, and if it's on, you get some brown nodes. So yeah, experienced users. Let's start first. The other place where LabVIEW shows the subarray is this one, the heap peak. Who knows the heap peak? So 20%, 40% maybe. Again, Google LabVIEW heap peak. You go to the Wikipedia. It's acquired taste, I think. It's so on one side you can learn a lot about how LabVIEW works from the heap peak. On the other hand, you need to know a lot about LabVIEW to understand the heap peak. But over here it shows, oh, I have animations. In the DS fields, it shows the distinction between subarrays and arrays. Of course, this is not automating, but there is a scripting node that actually returns this exact same information. Maybe Greg McCaskill knew this, but I don't think many people are aware of this. I hope I am allowed to tell it, but yeah. So this is still very tricky because the diagram needs to be in memory. If you just open a VI reference, the diagram isn't always in memory. This makes sure it is. There are more strings it will take as an input. Just saying. You could waste a nice afternoon exploring this node. Yeah. And if you don't have scripting, quick drop will work here. You can create an invoke node, switch it to VI, and then switch to this method. It's nice on the forum. You can just put this on the forum to tell you get this node by doing this instead of explaining how to enable scripting. Yeah. It returns JSON, JSON string wrapped in a JSON, but the string here isn't JSON. So this is still tricky because even if you use this method, there is a chance that the VI hasn't been compiled while it was in memory. So I check if there's an update flag. If this is false, then the VI needs to be recompiled. But I don't want to randomly run VIs that you are analyzing. So what I do, I pause it, then I run it. Immediately the VI will run into a breakpoint, and then I abort it. And then I do get the details, right? Yeah, well, that's scripting. I mean, sometimes you have to improvise. I think this could be better. This could be more deterministic. Not sure 20 milliseconds is always enough, but you can put it in a loop, of course. So from here on, it's pretty much straightforward LabVIEW. You get the string and you do string parsing. Here I just did some added some extra debug information. More string parsing. If you don't get this, dive into regular expressions. It's a one-time investment, and once you know, you will profit from it. Yeah. So this is just, I fill a column box with all the references. And this is from the heap peak. And this is a bit tricky because you need to get the source terminal of the wire, not the wire itself. And then we can put it in the event structure. And now I realize I should have started LabVIEW. LabVIEW 2024. What loads fast? LabVIEW? It's okay. You cannot see this. Let me go to the next slide. I'll just skip this. Windows P is duplicate. So don't call your VI list box just because it has a list box, but so yeah, this is the resulting VI. Everything is in there. This is a one-liner. It's don't program like this, but just for presentations, sometimes a one-liner is easier because you can get the overview without opening 10 sub-VIs. This is the magic VI, right? Exactly as the screenshot. Over here I did add a filter to only include the sub-arrays and substrings. And when I run it, I get, that's the breakpoint that I put there. I get a list box and I get an overview of all the arrays and if there are sub-arrays or not. And if I double click it, it opens the VI and highlights the wire. Yeah, so in the office you would probably put this on 2 screens or on your 24-inch monitor. And then you can develop, debug, test. You have a nice loop for optimizing your VIs. There's nothing exciting coming, but oh, I can show you this. This is fun as well. Let's remove the filter. That's fun. Now you get all the wires, right? And you can get a lot from this. For instance, this wire, this double, it's actually a pointer. So that tells us that LabVIEW doesn't even, if you index the array, you probably get a pointer to the original data. So even the individual elements are not necessarily copies. Now for a double, it doesn't make a difference, but if you have a class, then it would make a difference if you get a copy or a pointer to the class. Yeah, there's a lot of fun here. Controls are also pointers. All this information is just for testing this VI. I think there's more to get from this. It would be nice if you would have, if you know it's a subarray, that you have a pointer to the original source of the data. Anyway, maybe it's all in there, maybe it isn't. Maybe somebody from NI can tell. I don't know. But from now on, you can all explore this, and maybe it will get follow-up. Huh? That's from the beginning. Any questions? Yes, Norm.
So you were hovering over a wire to look at the context help to see what it was doing.
Yeah.
If you hover over one of the nodes, does it indicate as well whether or not it should be an array or a sub? Like ideally, it could be a subarray out.
No, no. So to repeat the question, the only way to get the sub-information is by hoovering a wire, not the node itself. I think it could be added to the help. But I think like the idea of LabVIEW is you don't have to worry about it, right? But sometimes you want to worry about it, or you need to worry about it. But, yeah. Yes?
Okay, no, I mean, I just want to make a few comments, right? So the aim of this is to understand how many allocations are being made and try to optimize it, right?
Yes?
Have you used the tool called profile buffer allocations? So all this information is more of static, right? You compile it and you see, okay, maybe I can avoid this copy, right? But there are a bunch of decisions that are made at runtime where you see that, okay, this is an array that I can reuse, right? So you don't go into the memory allocator and you just use it, reuse it, right? So there's a tool called profile buffer allocator, which at runtime figures out what are the allocations being made and then shows it to you. So you can figure out, okay, this is a copy and this is not a copy. So you could make more optimizations there.
So you can make more optimizations by analyzing
Yeah, I mean, like
the
the
buffer
information.
allocations?
Yeah, I mean, like if you look at what the allocations are, right, and then you said you can tweak this by adding a case structure this way or some tweaks, right, and see what optimizations you can make, right. And this is more of like static information, right. You compile a VI, you see that these are the wires and these are data types, and then you try to make some sense out of it, right. But a lot of information is more available at runtime rather than compile time, right. So the tool which we wrote like maybe 10 years ago called profile buffer allocations, it gives you more information about where the copies are being made, and it's richer than this.
So
right.
is that an open tool? Do you have that?
Yeah,
tool?
yeah, it's shipped.
It's shipped.
Yeah.
That is the show buffer allocations, or
The show buffer allocations is different. Like it's pretty old. There's something called profile buffer allocations.
profile buffer allocation.
Yeah,
Oh,
yeah.
In LabVIEW, okay. Well, I have LabVIEW installed. So.
Should be.
This one.
Yeah,
Ah,
yeah.
Okay.
So this,
Okay, but
You
you run it
start-
for all VIs?
yeah,
Okay.
start, run a VI, and then you should be seeing all the allocations.
Oh. Ah, okay.
I think
Well,
Yeah, lower the threshold.
or allocate bigger memories.
I would say this is
I think this is the minimum.
large allocations.
Okay, well,
Upward make.
we won't give up.
Yeah.
They're happy now. Let's see. No. Oh, this is still not that much. Yeah, 10 kilobytes. Yeah. Well,
No, that's a
Yeah.
that's a compile time allocation, right? If you do something like a init array or
init array, so it doesn't do constants. You mean?
yeah, I mean constants you know beforehand. Right?
Okay. Well, we don't have to explore it now, although I still have 30 seconds. So yeah. Well, thanks. I think I've saw it, but there's a lot in LabVIEW, and sometimes you just forget stuff that's there.
Another comment I had was there was this workaround to actually compile a VI, where you start the VI, pause it, and abort it, and all those things, right? There is a property node where you can just, or a method where you can just call, open a VI ref and ask it to compile, right? And then it would compile it for you.
There's a VI property
There's a VI method.
method that
Yeah.
returns metrics.
No,
To compile the VI.
it just compiles the VI. You don't need to do this pause and abort and all these workarounds
Oh, okay. There's a method
to compile.
to recompile.
Yeah.
Well, this one, VI. Oh, okay. And then you have to do the force compile, I guess, because, yeah.
Yeah.
Okay, so yeah, that would make life easier. Yeah. So,
And one last comment I had was the reason you need to compile the VI is when a VI is compiled, right, it has all this information about something called in-placeness, right? What is the allocation that I'm stomping on, or what is the allocation that I'm reusing, right? And at least LabVIEW doesn't think it's necessary to store it across the VI save and load sessions, right? When you save a VI, close it and open it, we don't think it's like absolutely necessary to store that because the compiled code is already there, right? The decision to run the VI in this way has already been made, so we don't really see a point in storing it, at least now. But if you think that's something that would be useful to see the static data or the wire data, right, whether it's a subarray or something, right, it's not too hard to store it and then like show it up. If you think, I mean, it's more of a behavior that was intentional than a bug, right? So, but if you think that is actually useful, we could just store it with the VI, and that would be helpful. Right?
yeah. Okay, so you're saying there are reasons why it happens like this, the help?
This is output from the compiler, which is not the code.
Yeah.
And we don't save it.
Yeah.
So it is an optimization.
Yeah, I mean, if you want, we could save it.
And I think it's even perfectly acceptable, those kinds of optimizations. It's just the help is kind of tricky because it is what people depend on. So it's,
Okay, yeah.
but yeah, maybe if it changes in the future and it is saved in the VI.
Sure.
Should only be a flag, right? Like a Boolean.
Yeah.
Okay, thanks. Yes.
Small question. This is array mem allocation VI, which you found. You said there are same things for strings.
Well, yeah, that's a good argument. I said that like the avoiding of copying that's mostly the same for strings, but the array mem information isn't there for strings. But the tool I showed does show all the substrings and strings. Yeah. Yeah, thanks.
Thank you.
Cool. Thank you very much. We'll take questions on to Pitfalls.